These are the structures for some lipid soluble vitamins. Vitamin A, which is also called as retinol, it is a part of visual pigment. Vitamin E, which is also an antioxidant. Vitamin D2, which is a calcium metabolism and bone growth responsible vitamin. Vitamin K1, which is a blood clotting factor. Now these are the structure for water soluble vitamins. Vitamin B1, vitamin B12, vitamin C, ascorbic glucoside, nicotinamide, erythrobic acid, nicotinic acid, vitamin B6 and vitamin B2. Now once we have seen the structure of the vitamins, we have to try to synthesize a few vitamins. One of them is vitamin C. So synthesis of vitamin C, ascorbic acid through glucose. In the first step, it is followed by Ruff's degradation. It is a step down process. That means if we have started with a 6 carbon atom component, we will be finishing with 5 carbon atom component. Now, glucose reacts in the presence of bromine and water to give gluconic acid. Aldehyde group get converted into carboxylic acid. This gluconic acid reacts with calcium carbonate to give a salt of calcium. Then this happens because COOH, it can be replaced by COO minus Ca2 plus. Then this component or the intermediate, it loses one carbon dioxide in the presence of iron and hydrogen peroxide, that is Fe2 plus and hydrogen peroxide, so that we will be getting a xylose. We will be getting a xylose component, which is an aldehydic component. So in glucose, where we are started with a 6 carbon atom component, we are ending in 5 carbon atom component, which is xylose. That is your step 1, which is called as Ruff's degradation. Glucose gets converted to gluconic acid, further get converted into calcium salt, loses carbon dioxide and gets converted to xylose. In the second step, Haworth-Hirsch synthesis of vitamin C or ascorbic acid. Xylose is converted into lixose. Now these two are epimers to each other, in which this carbon number 2, the OH is brought to the right hand side, and hence this becomes the starting material for ascorbic acid. Now lixose reacts with phenylhydrazine. Carbon number 1 and carbon number 2 are involved in this reaction, so that we get an osazone component. So lixose reacts with phenylhydrazine to give me an osazone component. This osazone component, in the presence of dilute HCl under hydrolytic condition, loses this hydrazine component, so that there is a formation of a aldehydic carbonyl carbon and a ketonic carbonyl carbon. Aldehydic carbonyl carbon and ketonic carbonyl carbon respectively for the carbon atom number 1 and carbon atom number 2. This component reacts with calcium chloride in the presence of KCN. Now here Cn minus attacks onto the first carbon atom carbonyl carbon, so that Cn gets introduced. Now the question is, why it does not attack the second carbon? This is because it is highly hindered carbonyl carbon, and only free carbonyl carbon can be attacked easily by Cn. So in this step, xylose gets converted to lixose, which reacts with phenylhydrazine to give me osazone. Further, this osazone, in the presence of dilute HCl, it gets converted to aldehydic carbonyl carbon and ketonic carbonyl carbon, in which the KCN will attack, so that Cn gets introduced. Now the job of Cn is, under hydrolytic condition, Cn gets converted to carboxylic acid. Now Cn is a very versatile group which gets converted to a carboxylic acid. which upon heating, this intermediate upon heating for 6 hours in HCl, carbon number 2 and carbon number 3 are attacked, so that there is a formation of a C double bond C. There is a formation of a C double bond C. This component upon hydrolysis, that is removal of a molecule of water under a harsh high temperature condition, there is a formation of a glycosidic linkage between 1, 2, 3 and 4. Carbon number 4 and carbon number 1 and carbon number 4 respectively. Now this linkage is called as glycosidic linkage. This component is called as ascorbic acid or vitamin C. So in this step, the CN which has got converted to carboxylic acid, when the component gets heated for 6 hours in HCl, carbon number C2 and C3 are attacked, so that there is an introduction of a double bond. This component loses a molecule of water, so that there is a glycosidic linkage between carbon number 1 and carbon number 4. We get ascorbic acid or vitamin C. This is how vitamin C is synthesized from glucose. The next synthesis is called as synthesis of vitamin A or retinol from Johnson's method. In this, the first starting material is 2,2-dimethyl cyclohexanone. Cyclohexanone reacts with soda-amide in the presence of methyl iodide through a Chichu-Babin reaction. In this reaction, a CH3 gets introduced adjacent to the carbonyl carbon. Now we can see that a CH3 has been introduced through methyl iodide through a Chichu-Babin reaction. Soda-amide acts as a base, abstracts the proton, in turn CH3 is introduced. This component number 1 reacts with 3-methyl octa 3,5-dienyl 1-in-7-ol, the long chain component, in the presence of lithium aluminium hydride and MnO2 in the presence of a base. In the presence of a base, here there is a carbanion formation. The carbanion attacks the carbonyl carbon. So first step is starting material 2,2-dimethyl cyclohexanone in the presence of soda-amide in methyl iodide. There is an introduction of CH3. This component number 1 reacts with 3-methyl octa 3,5-dienyl 1-in-7-ol in the presence of base and lithium aluminium hydride in the presence of MnO2. The base generates a carbanion at this yne position, YNE position, which attacks onto the carbonyl carbon. That attack introduces a long chain into the cyclohexanone component, so that now there is an OH. This OH can be easily removed by heating and removal by a water component. So OH is removed easily by heating. Upon the removal of this OH, there is an introduction of the double bond at this position. So removal of the water, there is an introduction of a double bond. This intermediate now reacts with ethyl 2-bromoacetate, that is BrCH2CO2C2H5 in the presence of zinc. This particular reaction is called as Reformatsky reaction. There is an end carbonyl carbon over here where a CH2 will go and attack. Now CH2 will attack onto the carbonyl carbon, so that an intermediate is formed. Now this particular intermediate is OH, CH2, CO2, C2H5. Now in this particular reaction, a long chain which was introduced, there is a presence of OH. This OH is removed by the removal by the heating, so that there is an introduction of the double bond. This upon Reformatsky reaction, there is attack onto the carbonyl carbon. In turn, once there is an attack, OH is formed and again a long chain is introduced. Now this is CH2, CO2, C2H5. This upon hydrolysis, this long chain intermediate upon hydrolysis, now CH2, CO2, C2H5 is converted to an alcohol, CH2CH2OH. Upon hydrolysis, the bromoacetate or the ester component is converted to CH2CH2OH, that is an alcoholic component, which upon removal of a molecule of water. So why do we remove a molecule of water? We want to remove this OH. In the presence of protonic environment, upon heating, we will be getting an retinol or vitamin A. So in this particular step, an ester which was present in the previous step is converted to an alcohol. Then there is an heating, so that there is a removal of OH and introduction of the double bond. In turn, I will be getting retinol or vitamin A. Thank you.